Hello, everybody, and welcome to today's webinar, Unraveling Gartner's Market Guide for Data Ops. We're just waiting for attendees to join, so make yourself comfortable, sit tight, and we'll get started in just a minute or two. All right, it looks like we're getting attendees settled in, so why don't we get started? I'd like to welcome everybody to today's webinar, Unraveling Gartner's Market Guide for Data Ops. Hopefully you've all had a chance to download the market guide, which you can do from the dataops.live website. Today, I'm thrilled to welcome as our host, Sanjeev Mohan, Principal of Sanjmo Consulting, expert in the data and analytics industry and a former Gartner VP and analyst on the topic, and also Guy Adams, co-founder and CTO of DataOps.live and co-author of both Data Ops for Dummies and Data Products for Dummies. And I should mention, Sanjeev is also a co-author of Data Products for Dummies. So two top industry experts here to unpack Gartner's Market Guide. Welcome, and let me hand it over to Sanjeev.
Thank you so much, Nick. And it's such a pleasure to once again work with Guy. Guy and I have a long history of collaboration. It's the book we co-authored. We've done a number of webinars in both in the US and in Europe, panels. So here we are once again. We get to talk about a pivotal Gartner document, which is called the Market Guide. Market Guide is a important document because this is when Gartner recognizes that there is a new emerging category and they write about what does that category contain. So they have some definition. They talk about what are the trends that are driving that. They come up with a list of representative vendors, but unlike Magic Quadrant, there's no evaluation of those vendors. So today we get to see who are these vendors in the latest edition. It is the second edition called Market Guide for DataOps Tools. And the first one came out in December of 2022, and the second edition just came out. Very exciting to see what are these trends. And before we go and we look at why is data ops so hard, I just want to mention some of my thinking on this topic. And Guy, this is something that you've not heard me talk before, so I'd love to see what your thoughts are. But this is how my brain started working. Lately, I saw on LinkedIn, there were a lot of discussions going on that those who have failed in BI will fail to do AI. And, in theory, it sounds pretty obvious. Yeah, if you cannot do BI, how in the world are you going to take a leap and jump many steps up and do AI? So it's true. But the problem, the real issue is hidden away in this statement. This is a classic example of when we say, do not confuse correlation with causation. So they're correlated. But what is the cause of failing in BI that will lead you to fail in AI is because you have not adhered to good data hygiene. You don't have good data discipline in place. You don't have good data management practices in place. And this is where I think data ops plays a huge role. And that is the thing we need to fix. We don't need to fix BI to be successful in AI. We need to fix what we call as data ops. So, Guy, just wanted to pick your mind and
Yeah,
see this. resonate.
Absolutely. I think that certainly that correlation, that axiom of if you failed at BI, you're going to fail at AI is 100% true. And in fact, I can give you an example from some work I did just over the last few weeks. We're releasing a blog and a video in the next 24 hours where we're showing using DataOps to fine train LLMs.
Hmm.
And we take an off-the-shelf LLM and we take some data and we fine tune it and we test the fine tune model. We make sure it meets certain scores and then we promote it to production. And in the middle of doing that, I made a mistake and I took my fine tuning data and rather than loading it once, I loaded it like 1,000 times. And when I fine tuned the model, it became massively overfitted because the fine-tuned data was repeating this, the fine-tuned data was repeating the same thing again and again and again. Now, if I was doing BI and I accidentally loaded the same data 1,000 times, pretty likely a business user, a human being, to look at that and say, hey, we didn't sell this much, or we don't have that many products, or whatever. There's a human sanity layer that can look at that and say, something's gone wrong here. Whereas, AI kind of, by definition of what it does, it puts an abstraction layer there that all I see is the output model. And I ask it some things, and I get some responses, but that obvious, glaring, this is completely wrong was missing. And it actually that existed in my pipeline for a good couple of days before I spotted what I was doing. And actually I spotted what I was doing not because the LLM was performing not quite the way I was actually trying to optimize the performance and suddenly realized I was doing something stupid. So, even as a relatively expert user, I was using a very bad LLM, a very bad fine-tuned LLM that was heavily overtuned through a simple mistake, and I didn't spot it. And so I think absolutely, if you haven't got those principles and those practices and that discipline and that process for doing this in the BI world, where you've got things, repeatable and automated, and you've got great data quality testing and automated testing and things like that in there, then you're going to come to the AI world and you're going to make mistakes because everybody makes mistakes. That's not a question. That's a statement of fact. But those mistakes are going to stay around for an awful lot longer, and those mistakes are probably going to have some significantly higher business consequences than they would in the BI world, where that human brain is going to stand and check and say, no, something's not right here.
See, this is so important what you just said, because in case of a CFO who's responsible for producing the financial reports because they are due to SEC or some compliance, some organization, if the CFO has an intuition that the numbers are not correct, then you can go fire up an Excel spreadsheet and you can munge around, you can fix these things. Because if you don't, then that CFO is going to jail. And you don't want to go to jail, right? But when you talk about like fine tuning an LLM, or some of the AI topics are so abstract that we may not even know that we made a mistake unless we have proper tools and practices in place.
Yeah, and ultimately, like, I mean, you take the example of sales data. Yes, if someone says, oh, we should run a special offer in this country because we've sold $100 billion of it, someone very quickly can say, well, we don't do $100 billion of revenue globally. There's a problem there. Whereas if you fine tune, if you've duplicated that data a whole bunch of times for one country and you fine tune your model and say, where should we run a special offer? It's just going to say run an offer on these products in this country. It's not going to say because of this enormous thing, so you're not going to get that kind of that obvious sanity check.
Yeah, very true. So let's get into the market guide. So according to Gartner, there are 5 capabilities, and you see here the ones in light blue on top, which are data pipeline orchestration and data pipeline observability, are a must-have. And then the rest 3, data pipeline test automation, deployment automation, and environment automation, are nice to have, or they call it standard capabilities. DataOps is not new. In fact, this is the second report, like I said. In both the reports, Gartner calls this category as emerging, but working with a lot of companies very closely, I think it's already emerged, and it's a pretty well-established category. In fact, some years ago, I think must be 4 or 5 years ago now, that some of people in the industry, like yourself, Guy, Justin, Wayne Eckerson, came up with this 7 pillars of data ops. So I want to ask you, can you go deeper into each of these ovals and tell us what are their functionality and why are these so critical to our data pipelines today?
Yeah, so I think there is definitely an overlap between the 7 pillars as we define them. For example, you've got things like environment management and test automation. Replicated pretty much for one. I think when we talk about the true pillar of DataOps, one of the things we've got to distinguish is between DataOps as an overall practice. So the 7 pillars of DataOps were not just focused on the technology piece; they were focused on the technology, the people, and the process, and all three things together. So when we've got things like agility, when we've got collaboration and self-service, when we've got the component design, the way that we actually design and structure software and configuration and code, those are more people and process. So some of those 7 pillars kind of don't crop up so much in the mock code because this is very specifically about the technology piece. This is about technologies and the vendors of those technologies. So I think the 7 pillars has a slightly broader scope, but there's a huge amount of overlap between the two.
Yeah. So if I may dial back, so the origin of data ops it comes from DevOps, and before DevOps, in early 2000, we in software development we started practicing agile development. So that was the best practices for iteratively developing software code. But then we decided that we needed more automation and proactively managing that software development. So DevOps came up. So DataOps, a market guide from Gartner, is about DevOps for data, but from a technology point of view. And your initial research covered people, process, and technology. So,
Yep.
okay.
Yeah.
So let's talk about technology. So let's start with data pipeline orchestration. What is data pipeline orchestration and why do we need it?
So I mean, in simple terms, everybody's data platform these days is a collection of multiple technologies. At its simplest, I've got some ingestion technologies, I've got some data transformation technologies, I've got some data quality and test technologies, I've got a cloud data platform itself, such as Snowflake. I might have a data catalog on the end of it. So I've got multiple moving parts, and to be able to do almost anything meaningful in DataOps world, I've got to be able to piece those together. None of those pieces works without the other ones. So orchestration is simply how we stitch all of those pieces together so that a pipeline is, well, I ingest some data, I transform some data, I test it again, I may publish it. If it's good enough, I'll update the data catalog and so on. One of the things that's worth mentioning about orchestration, it's one of the most I think overloaded terms in this space, because there's multiple different classes and types of orchestrators. So at one end of the spectrum, you've got the completely generic orchestrators. You've got the likes of Apache Airflow and the orchestrators from the cloud scalers, hyperscalers, and they're orchestrators, and they can orchestrate anything. But out the box, they orchestrate essentially nothing. They're very generic. They're just a framework that you have to then work on to put all of your technology in. So if you want to orchestrate a data catalog, you have to teach your orchestrator everything about talking to a data catalog or everything about talking to a data quality tool. They're very generic. They can do anything, but they're really just kind of a shell or a scaffolding that you've got to build on top of. Then at the other end of the spectrum, you've got tools which really are predominantly data fabric tools, which say they do orchestration, but really what they mean is they orchestrate their own stuff. So that you'll get tools that vertically integrated tools that are doing their own data ingestion, they're doing some data quality stuff, they're doing some data loading stuff. And when they say orchestration, what they mean is we'll orchestrate our own data ingestion job, our own data quality job, but they're not going to go out and talk to other tools. They're kind of vertically integrated. And then in the middle, which is kind of where we play, you've got generic orchestration. So it's not limited to any one vendor or every vendor out there, but that integration with the technology is already done. So, when we say we orchestrate data catalogs, what you mean is we've done all the work to talk to, the data catalog A, B, and C. So you just configure it up. And we've done all the work to talk to the ETL, ELT technologies, and we've done all the work to talk to the transformation technologies and so on. So that's kind of, you've got a range from like a generic framework that can do anything but does nothing out the box at one end. At the other end, you've got something that's, extremely locked down and only works within kind of one technology and one ecosystem. And then in the middle, you've got the data orchestrators, which are flexible enough to do anything, but pre-configured enough to do most of the things you want with a few configuration parameters out the box. So orchestration itself is a relatively kind of diverse term and takes quite a bit to to understand. I think the other one that that Gartner's listed as must-haves as observability is relatively.
Can I interrupt? Sorry, if you don't mind, because I want to just talk a little bit about orchestration from a vendor point of view, so that way people who are listening can understand. I really love the way you said that there is one category of orchestration which is just so generic. You can write whatever Python code you want in Airflow, but it's just super generic. It's just a shell for you to write, as opposed to very vertical, narrowly focused for a product. And then in the middle are the ones where the integration's already been done. So you can do configuration, but you don't have to write code. So some examples. If you look at something like dbt, now dbt we know is an excellent tool for data transformation. It has its own orchestration, but you won't find it in this market guide from Gartner, because it only does orchestration for dbt templates, and that's it. So you cannot use it outside. So I think that's the category, the vendor vertical only product specific. Now, if you look at the one in the middle, for example, your organization, DataOps.live, does orchestration for a vast number of products. I was talking to Roche folks a while back. Even last year, they had 30 different technologies that are pre-integrated, like that DataOps.live orchestrates. In fact, so for example, they use Colibra for data catalog, Monte Carlo for data observability, Matillion, Immuta for data access governance. So all those are being orchestrated through DataOps.live. In fact, Roche told me that if a vendor comes knocking on the door and they say, oh, we have this brilliant new product that'll make you very productive, the first step is to make sure it works on DataOps.live. It can be orchestrated through DataOps.live. Then it gets put into their collection of software tools. Is that correct?
Yeah, that is, and I'd say the majority of our customers have that approach. The prospect of introducing a new tool into their ecosystem that doesn't fit into the overall end-to-end orchestrated data pipeline is just kind of unthinkable. No matter how good that individual tool is in its own right, if it's not playing nicely with everything else around it, it's just not going to be a good fit.
That is great. Excellent. Thank you so much. So I hope that gives the viewers some idea as to the next topic that we'll talk about, which vendors made it into market guide and which did not. So now you know why something like dbt is not there, or some other ones. So let's go to one of my favorite topics, which is data pipeline observability. So please walk us through what is the purpose of this particular capability.
Yeah, so I mean, again, it has kind of multiple layers. I would say at the simplest, data pipeline observability is observability of the pipeline itself, which jobs ran in which order, how long they ran for, what the dependencies were. But in practical terms, it has to be more than that. So when we talk in the same way that orchestration has to be more than just saying, hey, run this job, and then sitting there, just twiddling your thumbs, orchestration has to be run this job, pull the logs back, pull the metadata back, analyze the metadata. Data pipeline observability has to be not just, hey, this job ran and it took 12 minutes. It has to be this job ran, it did this work, it produced these results, it produced these test results, make those test results available for other parts of the pipeline. So it's not just the the red green lights of what happened, but it's the layers beneath that, the actual kind of the substance, the story of what happened, because that's critical. That's critical for troubleshooting, that's critical for governance, that's critical for an intelligent pipeline that says, well, a job on the right hand side of the pipeline is going to make a decision about what it does based on the results of previous jobs. So if I've got I might be talking to 3 different tools that do data quality, because they do data quality very differently. I've got one that's much more deterministic, one that's much more heuristic. but I want to take the results of both of those and say, hey, unless both of those report data quality at a certain level, I'm not going to publish this. The data quality scores are too low. So, in that case, data pipeline observability is actually collecting data out of jobs earlier in the pipeline and using that to inform jobs later in the pipeline. So it looks quite simple to start with. Oh, which jobs ran and which jobs depended on which other jobs. But in practice, it's much more about the flow of meta information through that pipeline.
Yeah, and I also like it because sometimes there's a huge cost impact. Now that we are running most of these pipelines in the cloud, and if you have pay as you go or you paying for consumption, then any anomaly that happens in the pipeline can cost you an arm and a leg. So observability can help identify if something's gone wrong and put a circuit breaker and stop it, rather than either propagate bad data or let this job that's hung or in a loop run forever and incur cost. So it's all the three things come in the picture: quality, reliability, and cost.
And if I had done what I should have done, back to my LLM story, if I'd have put a uniqueness test on my fine tuning, it would have broken the pipeline immediately, and it would have saved me spending hundreds and hundreds of dollars fine tuning LLMs on vastly more data than they should have done. Because it'd be like, you shouldn't be fine tuning your data when there's lots of duplicates in it. So adding that simple test automation, which I guess is the next one to talk about, would have saved me quite a bit of time and quite a bit of money. So I'm still making mistakes all these years later.
Yeah, see, this is such an important point you raised, because one of the a lot of Gartner documents have something called strategic planning assumption, which in Gartner is called SPA. So, which is basically what is the prediction that Gartner is making for that particular category or report that they're publishing. In the 2024 market guide for DataOps tools, Gartner says that by 2026, companies that deploy DataOps will see a 10x increase in productivity. And from what you just said, Guy, I think you're already showing that. I mean, we are already hearing it from from the people that I talk to. For example, let's take the example of Roche. Roche used to launch a new data outcome once every few months, or a handful of them. Now they do 160 releases a month. So
it's more like 300 or 400 now. Since that interview was done by Gartner, because it's included in the market guide, I think that's gone up considerably.
So that's gone up even more. So when Gartner says by 2026 you'll get 10x productivity, I think already today we've got companies that are demonstrating that. Would you say so? Or
absolutely
more than that?
And I think as you mentioned, this is the kind of the second iteration of this document, and that number appeared in the first iteration. And the reason I think that's important is because the first time you put a document out there, you make a guess of some numbers, and they might be right, might be wrong, and then you do, as Gartner would have done, hundreds and hundreds and hundreds of interviews and inquiries between the first document being produced and the second. And the fact that, having spoken to hundreds of organizations who are doing this, when they wrote the second version of the document, they said, you know what, it would have been very easy for them to say, well, we thought it was 10, but actually speaking to people who are doing it, it's 5 or 6x. No, they're still absolutely bang on note. We've now spoken to hundreds more people doing it, and we are increasingly convinced and more confident that that number is a fair representation of the benefits that people get.
So you're saying Gartner's prediction is now fact-based?
I'm saying it's always going to be based on assumptions, but the number of assumptions and guesswork today is vastly less than it was in the first document, the version they wrote, and yet they're still prepared and happy to stick with that number. And that's the number very much aligns with what we're saying, but obviously Gartner have an even wider scope of hundreds and hundreds of organizations they talk to back up those numbers.
That is great. Yeah. So that great validation. Let's move on to data pipeline test automation.
So, I mean, we talked a little bit about it. Test automation is just fundamental, and maybe I can sort of I can talk about the bottom three together, because although I mean you express them as nice to haves, from a purist DataOps perspective, to me, these are as essential as anything. As you know, the top two are kind of about steady state, really, in many ways. The remaining ones are much more about what my development process looks like. We spend much more time working on updating our data products and our pipelines than we do just watching things running in steady state. It's actually, in many ways, it's the development and the iteration that's where we put all of our time and effort and cost and everything else. So things like environment automation, which says, hey, when a developer turns up to do some work, we want to give them this clean, isolated sandbox so they can move quickly. They don't have to worry about breaking things. They don't have to worry about breaking other people's stuff. They don't have to worry about other people breaking their stuff. In particular, they don't have to worry about breaking production. That environment automation to give them that safe sandbox to work in is one of the biggest factors that contributes to that 10x, because they can be productive within 30 seconds, and they can work incredibly quickly without having to check with people and coordinate with people or do anything else. So that's that's a big contribution to that 10x. Then you start talking about test automation, which is okay, that's great, but how do I know that the stuff that I've built hasn't broken stuff that other people have built previously? This might be version 200 of this data pipeline, this data product. That means there's 199 versions of this that have got work in them that I need to make sure I don't break. Now, clearly, to do that manually is almost completely impossible, impractical, and that's why you end up only releasing a few times a year in the old models. But test automation that says every time I write something new, I'll add tests for it, but when I run the test, I'll run the test for my new bit and for all the stuff that's come before it, so that I know in seconds or a few minutes with almost no work on my part at all that I haven't broken anything previously. That's kind of what we mean by test automation. And then the final thing is the deployment automation is great. So I've very, very quickly been able to iterate on my changes, make my changes, add my test to it. I've very, very quickly been able to validate that it deploys into my sandbox and it doesn't break anything that's come before it. Now, what is my process to get this from my feature branch into an integration branch, into QA or pre-prod, into production? And that's the deployment automation, is I should just be able to say, yes, I'm happy with these changes, create a merge request, have someone review it, and bang, it gets deployed to the next environment up, and someone else reviews it and it gets to the next deployment, the next environment up. So those three really work together to give you that. Between them, those three together give you that 10x. Fast development, fast knowledge that I'm not breaking anything that's come before, and fast ability to get those changes once I'm happy with them into development, pre-production, production.
Couple of points come to my mind. The first thing is we have a little bit of overhyped expectations from AI, and it's taking time. In fact, the idea was that in 2023, we would be doing experimentation, but by 2024, we'd be putting these AI pipelines into production. We know that we are still doing experimentation. So if we're still doing experimentation and at some point we'll graduate that into production, then all these three ovals at the bottom become extremely important.
Mhm.
So that's for AI workloads, because AI workloads are inherently a lot more expensive than data. We may be using very expensive GPUs, so making optimizing our use of the environment becomes super critical. This is not like, I started a Snowflake environment, went home, and it was just sitting idle for the weekend. This is like very hard to get skills and resources. So environment management becomes really important.
Mm-hmm.
Test management becomes really important. In fact, one of our friends is this guy, Miguel from OneWeb. And I think if I remember my memory, if I remember correctly, OneWeb runs about 1 million tests a quarter.
We're more than that now, but yeah.
Now I'm sure it's more than that. Yeah. So
I think
go ahead.
But I think just to pick up on that AI piece, it is a magnifying glass onto the problems. So if you think about it, let's think about two scenarios where we have change. Let's say we've built a pipeline. Let's say it's like my example, I'm fine-tuning an LLM. And let's say I'm fine-tuning it, I'm building an LLM to do automated responses in a call center, which is a great classic example for an LLM. And I want to retrain it once a day, once a week, once an hour, based on new tickets that where operators have put responses in, because that allow, each time I do that, I have a bigger corpus of information. I have a better LLM to do automatic responses. So that's fine. So what I'm gonna say, okay, my pipeline is going to, once an hour, pull the latest call records from the CRM system. It's going to retrain the model, and then what? First of all, we've got to have some sanity checks in that this model hasn't, just hasn't started hallucinating. It is one of the facts of these that you can make it's a butterfly effect. You can make a fairly small change to the fine-tuning data and have a model that suddenly performs radically differently. So you've got to have in there some automated tests, some sanity checks that say, you know what, this LLM is performing at least as well as the previous version. If it's not performing better than the previous version, then why deploy it? So you've got to have some way of scoring it. But that automation you're doing, potentially every hour. But then, of course, if I'm fine-tuning a model, this entire world is moving fast. The base model that I fine-tuned it against it's 3 months old. So there's probably a new one been released. So how do I check that the new one is more functional, is faster, is whatever? Now I've got to create a feature branch, because that's now an actual change to my configuration and code. I probably make one line of change, which is the base model I'm working against. And now I commit that, I run my pipeline, that retrains the model based on the new base model. And again, now I've got to have some sort of test automation that says, okay, well, this new model, is it better? Is it producing better results? So I think one of the things that, as we move from experimentation to operationalization, one of the things that people start to get their head around is, to fine tune a model or to retrain a neural network is great. But then what? How do I know that I can then go forward with this? What sort of automated tests can I put around it? Because, I can't just deploy it to production and hope that it's better because it's based on more recent data. It's based on a more recent model or a more recent base model. So that understanding of I've done something and now now how do I test that it performs better than its predecessor is an area that's kind of really important in all AI ops, but particularly LLM ops.
I have a theory that in our development practices, emphasis has shifted constantly. Some years ago, it was all on build, write the best program you can. And then when cloud became prevalent, then build became really cheap because anyone can go and have access to any number of tools. It was the runtime where the problem cost started going up, because if you ran it poorly, then the cost went up. And today, I think the pendulum has shifted even further to distribution. How do I deploy it quickly across all kinds of modalities, from edge devices to on-premises to different clouds, and deploy it fast enough so a lot of people can use it? Because I think once we get to that heavy, like major distribution, that is when software companies become or any company becomes really popular, well known, because now you have more users who can discover and use your product. So this build, runtime, distribute, I think now the focus in my mind is.
And I think that that's one of the reasons we like working with Snowflake capabilities so much, is because they provide that abstraction so that I don't have to worry about how my LLM works on Azure or AWS or GCP or whatever. I can operate at one level above that. I can operate at what I want it to do, and I can let Snowflake take care of how that works in different in different modalities, as you say.
That is great. This has been an amazing discussion. Let's pivot completely. And now let's look at who are the products or which companies made it in.
I think you're muted, Sanjeev.
All right, sorry about that. So this categorization is exactly out of the market guide. And so we are going to go through this, but then we are going to take this apart and discuss things from a different point of view. So Guy, please kick us off. What is a generalist, specialist, or an orchestrator?
So I think if you start with specialists are generally people that are providing, if I look at the range of things that are required for a DataOps platform, generally a specialist is providing very specifically one of those. It might be providing, it provides a very good way of doing test automation for certain types of data, or it might provide very specific types of observability. I would actually make a case to say the orchestrator category is really just another specialist, because it's really just another kind of pillar that you need. So it's a bit of a semantic difference, but each of those are providing a piece of the puzzle. The generalist category, as Gartner defines it, is a little bit broader. And in fact, maybe if we go to the next slide, I actually split generalist into two areas. There are generalists who kind of maybe provide more than one piece, so you can't put them into one of the specialist buckets. But then there are the generalists which provide an overarching scope, say, hey, actually, we do pretty much all of these pieces. Now, it doesn't mean, and to be absolutely clear, it doesn't mean that if you use one of the overarching scope technologies at DataOps.live or DataKitchen, doesn't mean you're not going to use some specific tools for test automation, or specific tools for data quality, or specific tools for data cataloging. You absolutely are, because one of the things that an overarching DataOps platform will have in it is great orchestration capabilities, which are pre-configured to run with all of those. So overarching, don't confuse an overarching scope with, hey, it's a vertically integrated platform that tries to do everything on its own. That's the opposite of what we're going for. But what it says is this is a one-stop shop where you can get kind of all of the DataOps pieces and infrastructure and platform that you need, and then you can plug in your ETL, ELT tool of choice, and then you can plug in your data quality tool of choice, then you can plug in your data catalog of choice. So it really comes down to kind of answering the question, what sort of organization are you? At the extreme end, you've got people that say, oh, we don't want to buy an orchestrator, we can write one. Okay, if you want to go out and write your own orchestrator from scratch, go for it. Very few people are kind of that insane in this day and age. Then you got people that say, okay, well, I think I could take an orchestrator and a test automation platform and an observability capability and a few other bits and pieces that that aren't on here, and I could configure them all up, and I could wire them up, and I could put all of my user access control and logging, governance, and everything else. I could build all of that. Then I could train my orchestrator or teach my orchestrator to teach all my tools. So you got people that kind of builders. They want to try and build it themselves from the building blocks. And you know what? Some people will do that and succeed. The majority of people that do that kind of fail because they grossly underestimate how complicated it is. Not partly because it is so complicated, but partly because everything is moving so quickly. Say, well, hey, we could do this in a year. Okay, great, but in a year's time, the world got 3 times more complicated. You're still a year or 2 years behind. Or you get organizations that say, you know what, we are an insurance company, we're a retail company, we're a manufacturing company, we're a pharmaceutical company. We're not a software development company. What we want to do is try and say, give me a platform that does 90 to 95% what I want, but still gives me the freedom to do the 5 or 10% that's kind of unique and bespoke to me. And that's kind of where we play, is, do all of that heavy lifting, give you that platform that's 90, 95% of where you want, but still with the flexibility and extensibility to close that gap that makes you unique and different to your competitors.
Yeah, very well put. I like the way you have broken up generalist into 2 separate categories, because when I first saw the list, it seemed like these were mutually exclusive categories, and a generalist is not mutually exclusive from an orchestrator, and it's kind of hard to show. It's not like a very simple matrix. It's a matrix of like capabilities. In fact, the orchestrator ones are very interesting, because if I go to the next slide, because my next slide here shows on the left-hand side, you see, by the way, just to mention, actually, let me go back here, because one thing that I want to mention, which the companies that are on this chart are super happy, but the companies that are not are irked. And they're like, so I get calls like this all the time. Well, why am I not in here? So that it's this, we're just sharing what's in the market guide. We don't have any control over it. But the important thing to note is that Gartner has a limit. Even for Magic Quadrant, they try to limit to 20 vendors in a report. And there are, I know there are 20 vendors just in the data pipeline observability space, including some that I've already mentioned on this call that don't show up here. And like even here, I would say Axel Data is a data pipeline observability. Unravel is caters to the FinOps use case. So there can be a lot of discussions as to why these companies were included and not others were included, but that is a discussion that is for Gartner to have. Now let's look at how has the market had changed between December 22 and this year. So on the far left, you see the 20 companies that were in 2022, and in 2024, you see Atlan is no longer in there, maybe because Atlan's orchestrator is now considered to be only for Atlan. It's not a general purpose orchestrator. So they've dropped out. You see a number of companies have dropped out, but in green, you see the ones that have been added. So so if you look at this list, 12 companies have made it between 2022 and 2024. 8 companies dropped out, and the ones in green are the 8 that have been added. But look at who's been added: AWS, Google, Microsoft. All hyperscalers have now are showing up, and they're all as orchestrators. But in addition to these 3, then the other ones that are added are things like Daxter and Prefect. So Daxter, Prefect, and Astronomer are basically pure play orchestration companies. And if you look at AWS, AWS is actually nothing but, like Astronomer, it's managed Airflow. So, and then of course, IBM is also in this list. So these large hyperscalers or cloud service providers, they are providing very generic capabilities that handle certain features like orchestration. But then I'm going to stop here, Guy, because I want to get your view into how has the landscape of vendors shifted between 2022 and 2024.
Yeah, I think and obviously, not talking about individual companies, but looking at a broad stroke, I think the landscape's changed for probably 3 reasons. I think the first one is just new technologies coming on stream, new offerings like AWS Orchestrator and things like that. So, or things that were, small scale have now become, large enough to be on to the Gartner radar. So there's just new entrants that deserve to be there, number one. I think number 2, a lot of the changes reflect what I've called for a number of years, DataOps washing, which is organizations that are, when a term like DataOps gets to a certain part of the hype cycle, everybody wants to slap DataOps on everything they do, and that caused a lot of confusion. And I think a significant number of these are where it's now become clear that that isn't a DataOps capability, or that organization has decided that actually just sticking DataOps on it when it isn't is not actually doing them any good. So they've kind of rolled back from all of that messaging. So I think there's some of that in there, and I think the third piece is just actually Gartner's developed a much better understanding of those different buckets. And in many ways, I think the generalist category, I think, has got smaller, because the generalist category, as we talked about in the previous slide, is a combination of overarching players, and then it's a little bit of a dumping ground of people that don't belong anywhere else. But I think as they've started to mature and understand those other categories, they've taken ones out of the other bucket, and they've actually replaced them with ones in one or more of the specific areas. So I'd say if I look across these, those are probably the 3 main things: new entrants, organizations where a lot of the confusion and the sort of the over marketing of the term DataOps has caused confusion in 22 and less so in 24, and where Gartner's just developed a better understanding and and more specific understanding of each of those buckets.
I would say so. Without going into specific vendors, some vendors were actually, when I talk to them, they don't even see themselves as DataOps. They do something entirely different. So, so we are getting a few questions. One question that somebody wants to know is, what are the challenges to doing DataOps? Any thoughts?
I would say probably the biggest challenge these days is really not technological. I think, those technological pieces are, we've been doing this for so long now. They are really, really well solved. They're really, really mature. I think it's much more, if you're going to have a challenge, is your organization ready? Are your people ready? Do you have the sort of buy-in? Because you're going to be working differently. And you're going to be you're going to be operating with the business differently. Your move to DataOps is also going to go hand in hand with being much more agile, which means that the way you interact with the rest of the business is going to change. Are people bought into that? And actually, much more often than not, the answer is not just that people are bought into it. They're actually desperate for it. Once they understand what it means, it's like, you go to a business stakeholder and say, well, we're going to change. Rather than asking you to give us a 10-page requirement document up front when you really know very little about what you want, we're going to ask you to give us a paragraph to start with, and then we're going to work with you 3 or 4 times a week to iterate that to what you want. The usual response from the business is an emphatic yes. That's what we've been wanting to do all along, and we couldn't. So but yeah, I would say that the main challenges are really not technological anymore. Those are something that, we can just deliver these solutions now, pretty turnkey into customer, time after time in a very short period of time, including customizing it to their specific organization. It's making sure that your people and your organization are in the right place and are bought in and engaged as to why they're doing this, and that they truly understand the benefits of it. And I'll give you a simple example. It sounds stupid, but the people, the data engineers, or whatever, doing the work, need to understand that a 10x efficiency improvement, as the Gartner report says, is not going to mean they need 10 times less data engineers. What it's going to mean is that massive backlog of work from the business that just isn't getting done at the moment can now actually get done. But but nobody's job's at risk. That's it sounds obvious, but you'd be amazed at the number of data engineers who are initially a little bit resistant to these things because if we put all this automation, if we get so much more efficient, will we still have jobs? Of course, they may not have visibility on the enormous amount of work that the business has got for them that they just can't process today.
Yeah, I completely agree. I feel the challenge is more on the people side, and like you said, not technology. I think it's an issue of mindset. Uh, the culture in an organization is such that it's do it yourself. Just keep at it. Like it's a very like if you talk to data engineers, like what's worked for me in the past, I just keep doing more of it. But your point just right now was that the data teams are getting very much inundated by urgent requests from all kinds of departments, and you can't keep up with that. So it's not about fewer data engineers, about doing more with the time, like focusing on high value tasks and not on redundant tasks like how long it takes you to serve an environment or manually test, things like that.
Yeah, and that I before starting DataOps, I was a CTO of a professional services company, so we were doing this for customers, and the ratio of time a data engineer spends between the actual amount of time they spend writing SQL or Python or configuration of actual functional work, the number of minutes they spend doing that, as a proportion of the total time they spend on getting a change done, which includes all of the management, setting up the environment, the manual testing, all of the deployment processes. It's not even 10 to 1. Like it's sometimes it's 30, 40, 50 to 1. It's literally you can spend an entire day getting a 5-minute change out the door, literally in some cases. So that in a lot of cases that 10x that 10x is an average, but in some cases that is 100x, literally.
So the next question is actually very interesting. It has to do with data products, and somebody's asking that data products journey. You guys wrote the book on data products. How can DataOps help me build data products and maybe even monetize them? Is anyone doing it?
I would turn the question round and say it's virtually impossible to meaningfully build a data product without data. So many of the characteristics of a data product, as taken from a software product, involve agility, involve rapid development, involve rapid time to value, I would say it's almost impossible to deliver data products in any meaningful way by any meaningful industry description. And I'm aware there are lots of them, but without without some sort of decent DataOps capability supporting all that, data products is really just a basic word, but it's not something that you're actually going to be able to deliver properly on.
And is anyone monetizing their data
Oh,
products?
absolutely, absolutely. In fact, we've got a customer who, I mean, relatively standard industrial customer, massive amounts of data. Business wanted to, understand what was going on, and they did all of the standard usual things, and it was great, and everybody loved it. And then they started saying, a couple of, very enlightened visionary people said, well, if we anonymize this, I wonder who else would be interested in this data, to the point when they've turned the entire data function of their organization into a profit center. That team makes more revenue than the team, the people, the infrastructure, the cost to the business. So they've gone from being an overhead to being part of the P&L of the company. And that, so many people think, oh well, that's fine for them, but nobody will want my data. It's incredible the value that your data can have to other people. And with things like the Snowflake Marketplace, that's becoming so easy now to kind of share and advertise and make available to other people. So we're seeing it happening more and more and more.
So that is a great note to finish our webinar today. So what you're saying is that data ops is helping or is sort of key to delivering data products, and data products in many organizations is going from being a cost center to a profit center.
Yeah, absolutely. And in fact, if you want, if you want an example, the most recent blog post, it's on our website, DataOps.live/blogs. I built a data product from scratch, from nothing, in less than 20 minutes without writing a single line of SQL or code. So if you want like an example of like when we talk about DataOps capabilities and we talk about the advanced edge of those, well, we've got a DataOps platform now has, Copilot capabilities and AI capabilities, so I can talk to it and it can build my data product, including Python UI applications, including data modeling, including automated testing. When I can start getting my data product built from scratch using natural language in 20 minutes and get it into production, that's how we start saying, how could you build data products any other way if you can get one out the door in 20 minutes using a proper DataOps platform.
That is great. Thank you. Before everyone signs off, just want to mention that if you go to my Medium blog site, sanchmo.medium.com, I also have a blog that I've written analyzing Gartner's Market Guide for DataOps Tools. Thank you so much, everyone, for joining today's webinar. Take care. Bye.
Thanks, everyone.